All right. We'll get started. Okay, so this is our last week of class, and then next week you have the final exam, and that will be it for our time together. So anyway, it's been a pleasure being your teacher. You should have all received an email. I apologize. I thought I sent them out yesterday, but I use Outlook to send these out, and I forgot to click send everything, and so it was sitting in my outbox. It's like internet mistake 0 or whatever. So anyway, you guys should have gotten them like an hour ago. All right, and if you haven't, when you go home and you check your email, it will be sitting there. Okay, and it just tells you at the end of the email exactly if you want this grade, you've got to get this on the final. Okay, and that's that. Okay, so if it says you need to get 73% for a B, you got to get 73% for a B. Okay, if you get 72%, then you'll be the grade below, B minus or whatever. Okay, so that's just how that works. So next week's the final exam. I'll provide the Scantrons. You guys come here a little bit before 7 o'clock, and we should be good to go. Are there any questions about, I don't know, anything? Yes?
Will you provide the Z and T scores?
Yes, I will provide the reference tables, okay? I will use the ones that are in your book, okay? So the reference tables that are in your book will be the reference tables that will be attached to the exam. I know there's reference tables online that are just a little bit different, okay? I should fix that. I'll use the reference tables from the book. Yes. Anything else?
How long is it?
50? About 50 questions, all multiple choice. You'll have 3 hours to complete it. That's more than enough time. I mean, a few of you will take all the way till the end, but I think last quarter maybe it was only like 2 students who were left at the end of 3 hours, so it's more than enough time. 80%-ish from stuff after the midterm, about 20% questions from before. The questions from before the midterm will be kind of just conceptual questions, non-calculation. Either you know the answer or you don't. I think there were a few of those in the practice final, which we'll go over. Yeah, the final counts for a lot, so study and get ready for that. Yes.
Will you email us the results?
Yes. So as soon as I get the finals graded and the grades tabulated and figured out, I will email you your results. Okay. Yeah.
How long does it usually take for your students to get like the transcripts from here, like once you're done with the grade?
All right. So after I email out the grades to you guys, UCLA Extension usually gets them processed within 24-48 hours. Okay, and then you will contact the records office for transcript. Okay, so you contact the UCLA Extension records office after your transcript. Don't ask me. So because I just send you an email. That's it. Okay.
How long before you ready?
Give me a few days. All right. I had to go to the Scantron machine. That's it. Okay. But it's just I don't have a Scantron machine at home or something. I just have to make an appointment with the office. All right. I hope you guys all have a copy of the practice final exam with you guys, because that's what we will be going over today. If you don't have one with you, I don't know, find a neighbor who's got one or something. Otherwise, today's review session might feel a little odd. Okay? Yeah. And then I have copies of the study guide, which is kind of like this, I don't know, kind of a almost like a step-by-step, you know, what do you do in this scenario type of thing. I don't know if it's fully step-by-step, but I think this is also very good. I have a few extra copies, so if you don't have one, you can take one, and if you have one, that's great. I'll just pass. Oh, okay. There you go. And I don't know if I have enough for everybody, so just take one. They're they're available on the website on the about the final. Nothing's changed. It's exactly. It's exactly the same, as what's on the website. Okay. If you have an iPad or something, you can go on the website right now and download and look at it there. It's exactly the same. Okay. So. Yes. I will provide the scantrons. Okay. All right. So yes, for next week for the final exam, bring. This is what you need to bring. You need to bring your calculator. Okay. If you forget your calculator, you're going to be in trouble. All right. So please, please, please do not forget your calculator. You know, make sure you have a pencil and a good eraser, all right? In case you need to change something on your Scantron, you've got to have a good eraser. So pencil, eraser, calculator, and you're allowed one sheet of notes, okay? You can write whatever you want on the note sheet. That's good. If you want to use this study guide as your note sheet, that's also fine, okay? And you can use this, and if you want to, you know, there's a little bit of extra white space. You want to use a pen and handwrite some extra notes in there, that's fine. If you're going to do that, I recommend using a different colored pen for the extra handwritten notes, so your eyes don't bleed. But if you want to use this as your thing, that's also fine, okay? So, you know, I try to. I want you guys to pass my class, but I also have to make sure you actually learned something in this class, okay? Or I have to feel comfortable that you can do some statistics for me to give a passing grade. So, but I really want you guys to pass. I really do. So we're on the same team here, okay? This, and I need this, all right, well, shall we get started then? Okay. Okay, so this is just directly from the practice final exam. So on the final exam, you'll have a similar section as well. And I'm going to just list up a few scenarios kind of like this, and I'm going to say, were any of the conditions violated, okay? And your conditions are independent, random, big population, large sample. Those are your choices, and then if you think none of the conditions are violated, say none of the conditions are violated. Okay. Question 1. A study is performed to understand the relationship between bright lights and headaches. 80 randomly selected subjects are exposed to bright lights, and 20 complain they experience headaches. 90 randomly selected subjects are exposed to less bright lights, and 12 complain about headaches. Are any conditions violated? Okay. So let's just run through these. Okay. So is independent random met? Yes or no? Yes. Okay, so this one checks out. Why? Because when you read through the thing, it says they were randomly selected. Okay, so you can underline randomly selected, and that's how you know independent random was met. Okay, big population. Oh, question.
If you say random, can we assume that it's independent?
Yeah. So independent or random. We go together. Okay. So let's check the big population condition. All right, is that met? Okay. So here, all right, what was our sample? Our sample size is, for one, it's sample size of 80, and then the other, the sample size is 90, okay? All right. Is our population of everybody who might be exposed to bright lights or less bright lights bigger than 10 times this? Yes, okay. There are potentially more than 800 people that could be exposed to lights and more than 900 people that could be exposed to lights. So, so the population has to be over 800, and that makes sense. And over 900 over here also makes sense. Good, okay. And a large sample condition. Is that met? Yes, okay. So we check either n times p has to be greater than or equal to 10, and n times 1 minus p has to be greater than or equal to 10. The other thing, if here there's no p given, okay? So there's no p. So when there's no p given, you just look at the numbers themselves, okay? So here we have 20 people who are exposed to headaches, okay? 20 is bigger than 10. So that meets, okay? And then if 20 experienced headaches, that means 60 people did not, okay? So 60 is also bigger than 10, okay? So this is 20 who have headaches, and then 80 minus 20 is 60, okay? So that checks out. And over here we have 12 who had headaches. That's bigger than 10, so that checks out. And then what number do I look at over on this side? 90 minus 12, which is 78. And that's bigger than 10. So that also checks out. Okay? So all of the conditions here are met. So your answer for number 1 is D. Yes?
Why are you using 10 over 10?
So for the large sample condition, NP has to be bigger than 10, and n times 1 minus p has to be bigger than 10. But when p is not given, just use the counts in the problem, which was 20 people had headaches, and 12 people had headaches. And if 20 people had headaches, that means 60 did not. That number also has to be bigger than 10, which it is. And if 12 people had headaches in the other group, that means 78 did not, which is also bigger than 10. All right, number 2. Okay. A researcher wants to make a confidence interval for how common a certain disease is. He finds 300 randomly selected subjects and finds that 2% of them have the disease. Are any conditions violated? Okay. So here, yeah, is random met? Yes. So that one checks out. Big population. Is that met?
Yeah.
Yeah. Okay. So our sample is 300, which means our population has to be over 3,000. And what is our population? It's just people who might have, people who may or may not have a disease. Are there over 3,000 people? Yes. Okay. What about the large sample?
No.
No, that one's not met, right? We check n, which is 300, and p, which is 0.02, and we get n times p is equal to 6. All right. That one's not bigger than 10, so that doesn't meet. Okay. N times 1 minus p is 294. That one's bigger than 10. So that goes, but this one's not bigger than 10. So the large sample condition is violated. So your answer choice is C.
Was that number again?
294. N times 1 minus p, right? So 300 times, 300 times 0.98. 1 minus p is 0.98. A student has to conduct a survey for a school project. He goes around the campus and interviews people he meets. He finds data from 100 people and finds that 45 of them answered yes to his questions. All right. Any problems there?
Yeah.
Okay, what's that? Yeah. Okay, it's not random. All right, he's going around surveying people. So condition A, random, is violated. Okay, we could check the other ones. Big population, as long as the school has more than 1,000 people, right? So is okay as long as the school 1,000. All right, which it's not specified in that problem. I'll try to be as specific as I can. Okay, and then large sample. That one's okay because you know 45 is big. Again, n times p has to be bigger than 10, but p is not given, so we just check the numbers. 45 is bigger than 10, and then I do 100 minus 45, which is 55, also bigger than 10. Okay, and question number 4. A company wants to survey its employees. It has 800 employees, and it decides to select 100 of them and interviews each of them. Okay, are any conditions violated?
Yes.
Yeah. Okay, so the random is met because it says so. It says randomly, selected randomly. All right, but then the big population is violated because our sample is 100, which means our population needs to have at least 1,000, right? Times 10, and we only have 800. Only 800 in the population. Okay, and then as for large sample, we have no idea because it doesn't say anything. Okay, so if it doesn't say whether it is met or not met, you know, don't say anything about that. But the big population is clearly violated, so we can say big population. Yes.
I don't get why number 2, the large sample is violated.
Because I'm checking n times p has to be greater than or equal to 10, right? So my n is 300 and my p is 0.02.
Oh.
And so when I do n times p, I get 6. And 6 is not bigger than 10. Okay?
I have a question about 4. Isn't n the 800? Wouldn't you multiply that by 10?
No, my sample size is 100. 800 is the population. Because we're taking a sample of employees. So the I'm not interested in the United States or anything like that. I just want to know opinions within the company. So my population that I'm interested in is the 800 employees total at the company. Okay? And my sample is I'm taking a sample of 100 people. So that's what I have there.
And then, wouldn't it be 100 times 800?
So I do 10 times my sample, right? To check for the big population. So 10 times my sample is 100, 10 times my sample is 1,000. Okay? And I have to make sure that my population is at least 10 times my sample. So 10 times my sample is 1,000, my population is 800. 800 is smaller than 1,000, so my big population condition is violated.
Can you say again, why did we do 90 minus 12?
Okay, so for number 1, all right, we're checking n times p has to be bigger than 10, okay? But p is not given, all right? So in those situations, we say 12 people experienced headaches, okay? So how many people didn't experience headaches in that sample? Okay, well there's a total of 90 people in the sample. So if 12 of them had headaches, then that means 78 of them didn't have headaches, okay? And both of those numbers have to be bigger than 10. Okay, is this part good? All right, and you'll probably see about 4 questions or so, 4 or 5 questions on the final exam, just like this, okay?
On one of the quizzes, you gave us how big the population was. Will you do that?
It depends on the question. So on one of these questions, I told you how big the population was, right? I said there's 800 employees, okay? And some of the questions I won't specify how big the population is, okay? It'll just say something like randomly selected people, okay? And so the population will just be all people ever, and then you know that's a very big number. right, so let's get into some of these problems then. All right, questions 5 through 10. It talks about a farm. It says a farm wants to test 2 different diets for their cows to see which diet causes more weight gain. All right, and so they randomly select 10 cows to give diet 1, and 12 cows for diet 2. After 2 weeks on diet 1, the 10 cows gained an average of 15.2 pounds with a standard deviation of 4.1. After 2 weeks on diet 2, the 12 cows gained an average of 12.6 pounds with a standard deviation of 3.4 pounds. The following questions refer to a 95% confidence interval for the difference in average weight gain. All right, so let's just write this down. I've got diet 1, diet 2. Okay, so how many cows
10.
are on diet 1? 10, right? So N1 is 10. And what is the mean? X bar
15.2.
is 15.2. And the standard deviation?
4.1.
4.1. Okay, this is for diet 1. And then for diet 2, N2 is 12. X bar 2 is 12.6. And in standard deviation for 2, S2 is 3.4. Okay. All right. So we're going to answer questions about a confidence interval. All right. So the first thing we have to ask is, are we dealing with means or proportions? Means, right? So it gives us the mean and the standard deviation. So this is a clear indication that we're dealing with a numeric variable. So we're dealing with means. Okay, and do we have 1 sample or 2 samples? 2 samples, okay? So every time you go through a problem, all right, and you see, kind of a set of these questions, your first thing should be, am I dealing with means or proportions? Do I have 1 sample or 2 sample, okay? Because this is the most important step. If you screw this up, everything else about the problem is going to be bad, all right? So make sure you know this is means, and this is 2 samples. Okay. All right. So now that we've established means in 2 samples, then we can say, okay, confidence interval or hypothesis test. Well, it says we're going to do a confidence interval. Okay. So if you look at your study guide, okay, once you've established that you're dealing with means, 1 sample, 2 samples, there's a bunch of questions here that kind of line up with the types of questions that I might ask on the final exam. Okay? So the first part says, for a 95% confidence interval, what will be the center of the interval? Okay. Well, if you're not sure, you can go to your little study guide, okay? And the first question right there in that section says, what is the center? Did everybody who needed the study guide get a study guide?
Is it exactly what you got on the
It's exactly what I have on the website.
Yes.
So right there, halfway down on the first page, what is the center? Okay, and it says, all right, for 1 sample proportion, 1 sample mean, 2 sample means. That's what we're dealing with. For 2 sample means, it's the difference between sample means. So the center is x1 bar minus x2 bar. Okay, so in this case, 15.2 minus 12.6. The center of my confidence interval is 12.6. That's number 5. I'm sorry, 2.6. 2.6. All good?
Yes.
All right. The next part. What value will you use for T star? 6. What is T star? Okay. So T star is our critical value, right? What is our critical value? All right. So for 1 sample and 2 sample means, the T star value comes from the T table. And we got to figure out our degrees of freedom. So how many degrees of freedom do we have?
9.
9. I do n minus 1, but I use the n that's smaller. So I've got 10 or 12. I'm going to use 10. I do 10 minus 1. And I get 9 degrees of freedom. Again, if you weren't sure about that, right there, critical value, the degrees of freedom for 2 samples is going to be n minus 1, and you use the n of the smaller sample, written right there, also on your study guide. Okay, so now I go to my T table, and I'm looking up 9 degrees of freedom for 95% confidence, right? It says 95% confidence, 9 degrees of freedom, 2.262. So far, so good.
Do you have an extra one of the t-shirts?
Extra tea tables?
I mean, yeah, the.
I don't.
Oh.
I'm sorry. I feel like I've passed out tea tables 3 times during our course here. So you should have one. You should have one. All right.
If we don't say the number and we round down, do we always round out? Like if we don't
Yeah.
have
Okay. So
39?
let's say you get some number like 39.
Yeah.
Okay. 39 is not in your tea table. Then you always round down to whatever the closest thing that shows up in your tea table would be. Okay. So in this case, 39 doesn't show up, so you would round down to 30. Even though 40 is closer to 39, always round down and go with the one that shows up here. So you use 30.
What if 35 was there? We would go to 35?
Yeah, if 35 were in the table, you would go to 35, okay? And of course, if 39 is in the table, go to 39. Right? You go to the closest one that's in your table. But down. Yeah. Okay. Alright, what is the standard error? Okay. So the standard error, in this case, when it's 2 sample is going to be s1 squared over n1 plus s2 squared over n2. Again, if you forget these things, what is the standard error? That's listed right there. And you just got to know, am I dealing with 1 sample proportion, 1 sample mean, or 2 sample means? Okay? 2 sample means, again, the first thing you got to do, each problem, dealing with 2 sample means, and boom, written right there, s1 squared over n1. Okay, so here, I do 4.1 squared over 10 plus 3.4 squared over 12. Okay. Yeah, you got to punch this into your calculator, and you get 1.626. Not all, but a lot of the answer choices in the exam will be written in this form, okay? So you can see, did I plug in the numbers, okay? So that should help you guys out, make things a little bit faster, okay? Not all of them will be that way, but a lot of them will be, okay? And a lot will be similar to this, but wrong, okay? And you got to be careful, all right? Because if you see this, 4.1 over 12 and 3.4 over 10, that's wrong, okay? Because we're mixing up our ends, okay? So, you know, if you do the right answer, you got nothing to worry about, okay? But there will be similar looking answers that are wrong.
Pastor John, for number 6, how come you chose the sample 1?
Okay, so we use n minus 1, but we use the n of the smaller sample, okay? So again, that's written right here in our study guide. It says degrees of freedom for 2 samples is n minus 1, and we use the n of the smaller sample, okay? So again, I got 2 samples. One has 10, one has 12.
Yeah.
10 is smaller than 12, so we use that one. Number 8. All right. Create a 95% confidence interval in average weight gain. Okay. So now I'm going to put 2.6 in the center, plus or minus my margin of error, which is going to be my t star 2.262 times 1.626. Okay. So on one end I have 2.6 minus my margin of error, which is I don't know. Well, you get something here, okay? And on the low end, you get negative 1.078, and on the high end, you get 6.278. Okay. In the answer choice, this might be written in bracket form, which puts the low end on one side of the bracket and the high end on the other side of the bracket. Okay. So you might see answers written in this form. so just get used to that. Is that all right?
So that what we're looking at is correct.
This right here is the answer.
So just remember low end, high end.
Yeah, low end and high end, okay? It might be written this way, it might be written this way, alright? It may even be written like this, okay? These are all saying the exact same thing, it's just one is like, whatever, I don't know. So, yeah, they're kind of like in raw forms and into more, I guess, refined forms, but they're all the same. Going on. Based on your confidence interval, do you conclude that there is a difference in average weight gain? Okay, is there a difference in average weight gain? So how do we check if there's a difference in average weight gain?
Zero.
Yeah, okay, so when we are checking for two sample means, what we're looking for is 0 in the interval, okay? And again, that's written right here in your thing. So if it's one sample, you're looking for a particular value. If it's two samples, we're looking for 0. So is 0 in the interval? Yes, all right. Because our interval goes from -1 to +6 point something. So 0 is in between there. Okay? So 0 is in the interval. Okay? So that means we do not have evidence that there's a difference between means. Yes.
Can you open that again, please?
Okay. Which part? This is
Where is
So
zero?
zero's in the interval.
Where is 0? Okay.
High and low is the
You mean the zero that's literally written in?
No. Okay. So just imagine the number line, right? So I'm going from -1.078, and I'm going to 6.278. Okay. The question is the number 0 is the 0 in between here and here, or is it outside of the interval over here, or is it outside the interval over there? Okay. Well, 0 is in between -1 and 6. Okay. So basically, if your interval goes from negative to positive, 0 is in there. Okay. If your entire interval is positive or your entire interval is negative, 0 is not in there. Okay. So 0 is in our interval. So that means we don't have evidence of a difference between means. Okay? You're going to see in the multiple choice, there's going to be similar sounding answers that are wrong. Okay? You'll see something like 0 is in the interval, so we do have evidence of a difference. Okay? That one's wrong. Okay, so you got to know. You got to know what you're doing. You got to know what you're doing. All right? So I think those are fair questions. All right? I think, like, if you're going to go through this class and you're going to say you understand statistics, you got to be able to say, if 0 is in the interval, then I don't have evidence of a difference. Students complain I'm trying to be tricky. I'm not. I just want to make sure you really understand. Alright, so if instead we made a 90% confidence interval, how would it compare to our 95% confidence interval? Okay, I would use a different t-star, right? So for 90%, my t-star is smaller. So that means the width of the confidence interval gets smaller. Okay, so the width is more narrow. I don't know if that's written in the study guide. I mean, that might be some of the extra notes that you might have to write. I don't know. What does it talk about? Oh, it does show up there. Okay, higher confidence intervals make wider intervals. Look, zoom it in there. All right. Okay. Yeah, it's a study guide. It's not everything ever. Okay. I think it's pretty good though. Alright, let's see what we have going on next. Number 11 to 16. Okay. Alright, at the ruler and yardstick factory, a machine is suspected to be defective. Okay? The yardstick it produces are supposed to be, what, exactly 3 feet long, right? If you're making yardsticks, they should be 3 feet long. And you measure a random sample of 40 yardsticks and find that the average length is 3.02 feet. Okay. With a standard deviation of 0.03. Is this evidence that the machine is producing yardsticks that are too long? Okay, so this is 11 to 16. So, are the machines, is the machine producing yardsticks that are too long? Okay, so for this, am I dealing with means or proportions? Means, right? We're looking at the length of a yardstick, so that's a numeric variable. So we're dealing with means, okay? Length of a yardstick, so I'm dealing with means. And do I have one sample or two samples? I've got one sample. Alright, so now that I know I'm doing means with one sample, I can go on, alright? Okay, so this, as soon as you start reading it, you can tell, alright, it's asking questions about test and for a hypothesis test, okay? So we're going to be dealing with hypothesis tests. That's going to be on the back side of your study guide. Alright, so the question is, what would our, is this a one-sided test or a two-sided test? Yeah, okay, so you read the question and you see the phrase too long, okay? So here we are interested only if our yardsticks made, if they're too long. Is that the problem that's going on? Okay? We're not, it didn't say are the yardsticks different. Okay? So too long, that implies a direction, and so we have a one-sided test. One-sided or one-tailed test. Alright. So what would our hypotheses be? What is our hypothesis?
I don't get it. I don't get number 11.
Okay.
Why is it too long? I mean, why is it one-sided if it says too long?
Okay. So if you have words like different, changed, things that don't imply a direction, okay, things that don't imply that we're expecting something to be bigger or smaller, that's going to be two-sided.
Okay.
Anytime we see something about is this one larger or is this one smaller or something like that. So too long implies a direction there. So it's going to be one-sided.
But for two-sided, will you usually always say like not equal to or different or change?
Yeah, I'll use a neutral, direction neutral word, okay? So, yeah. I think all of my questions are going to be written fair. And if, you know, if during the test, if something is ambiguous to you, okay, just raise your hand and ask a question, okay? The worst I can say is, I'm sorry, you should know this answer and I can't answer it, okay? That's the worst I can say, okay? If it's something, if you're unsure about something, you can ask and I'll try to answer it. And if it's something that the test is actually testing, then I'll say, you know, I can't answer that question, okay? But right. So we're gonna say for what the hypotheses, okay? All right. So our null and our alternative hypothesis, okay? Again, if you're not sure how these should be written, all right? Because we're dealing with means, we're gonna write mu, okay? This was a common mistake I saw in your guys' quiz number 4? You guys didn't write mu, you wrote p, or you wrote x, or you wrote something there, okay? So the null hypothesis is that the yardsticks are indeed 3 feet, and the alternative is that they should be greater than 3 feet, okay? So you got to use the numbers there, okay? Same number appears in both of those things, okay? So that's number 12. All right. 13. What is the value of the test statistic? Okay. So in this case, that is going to be what we observed minus what we expected divided by my standard error. Okay. My standard error, if you're not sure, is going to be s over the square root of n because it's one sample mean. So again, determine the standard error. So s over the square root of n for one sample mean, also written in your study guide. So here, my stand is 0.03 divided by square root of 40. Where's my calculator? So this is a tiny little number here. 0.00474. 47434. Okay. So I heard someone calling out 4.7. Be careful. There's probably 4.7 e to the minus 3. So sometimes your calculators will report scientific notation. Okay. So be careful. All right. So if your calculator reports 4.74 and then there's a e minus 3 or something like that, that means this minus means move the decimal over to the left 3 spaces. So you go 1, 2, 3. Your decimal's really there, and you have 0.0474. Okay, because that's a huge, huge difference. All right. So don't. So if you see that in your calculator, all right. So just make sure you understand your calculator's notation, which. If it shows in like time e to the minus 3, it's generally what happens with graphing calculators. I think that type of calculator shouldn't be doing that. Is it? Okay, you got to switch modes to norm 2. So you're going to hit like shift setup, and then I think option 8 is norm, and then option 2 is 2.
How many numbers do you like us to keep?
It doesn't matter, okay? All right, because it's multiple choice, all right? So what's going to happen is if you didn't keep enough decimals, your answer won't line up with one of the answer choices, okay? Now, all of the answers that I've calculated, I've kept all the decimals, okay? So generally, if you didn't keep all the decimals, you'll get some answer that's very, very close to one of the answer choices. And if you keep all the decimals, it should be nearly identical to the answer choice there. Okay, so this is my standard error. So what I observed is what my sample says, which was 3.02. Okay, so at 3.02, what I'm expecting is the number in my null hypothesis, which is 3, and I'm dividing by my standard error, 0.0047434, and the number I get there is 4.216. Okay. So that is my test statistic. 14 says find the p-value of this test. Okay. So here, how many degrees of freedom do I have? I have 39 degrees of freedom, right? 40 minus 1. Okay. So we go to our t-table and we're looking for 39 degrees of freedom, and we don't find 39 degrees of freedom. What do they do in my t-table? Okay. So I don't find 39 degrees of freedom, so I'm going to use 30 degrees of freedom. And so I look, and here I see numbers like 2.750, and then 3.385. Okay, and this corresponds to 0.005, and this is 0.001. And I have 4.216 is beyond 3.385. So that tells me that if I were to draw a cutoff line there, the amount that's in my tail is going to be smaller than 0.001. Okay? So my p-value is going to be smaller than 0.001. Do I need to double this? No, I don't need to double it because it's a one-sided test. Okay? If it's a two-sided test, I'd have to take this number and double it. So my p-value is less than 0.001. Yes?
Just to clarify, so when we find the p-value for the test and it's not with a confidence interval, we just find out where the answer is in between the numbers? Like you
Yeah. So if my number was 3, I would say it's in between this number and this number, and my p-value would be between these two numbers, okay?
Right.
And in this case, it's beyond 3.35. I don't have any numbers beyond there, okay? So then, it's not going to be between a number because there's only one side over here, okay? So all I know is that it's smaller than this number. So smaller than 0.001.
Right, but if it were between
Yeah, if it were between two numbers, then my p-value would be between the two.
Where it lies, if it's before or after.
Exactly.
Okay.
It would be between the two column headings. If my test statistic were between two numbers. Okay. All right. So number 15 says, if alpha was 0.05, what is your conclusion? Okay. My p-value here is smaller than alpha, so we reject the null hypothesis. All right. And that means we have evidence. What? Evidence that
some of the yardsticks are larger.
that the machine is making yardsticks too long. All right. If this was a mistake, if the conclusion you just made was wrong, what kind of mistake did we make? Huh? Alright, right, so there's two types of errors we can make. We can reject the null hypothesis when the null hypothesis is true, and if the null hypothesis is false, the other mistake we can make is we didn't reject the null hypothesis. Alright? So in this case, we rejected the null hypothesis, and if that was a mistake, then that would be a type 1 error. Okay? So if we rejected H0, and that was a mistake, then that is a type 1 error. Type 1 error. Alright, that was okay, right? Okay, and then again, all of these, if you got questions, you can view some of the similar videos, I think. 17 through 22, it says researchers believe that 14% of the population is left-handed. A local school decides to see if their students have a different proportion of left-handed people. The school has a total of 1,500 students, and they randomly select 90 students for this study, and they find that 15 of them are left-handed. Is this evidence that the proportion of left-handed students at the school is different from the population proportion? All right. Okay, so are we dealing with means or proportions here? Proportions, right? We got proportions, all right? And we know this because it's a categorical variable. Is a student left-handed or right-handed or ambidextrous or something? That's a categorical variable. And do we have one sample or two samples? I've got one sample. I've got one sample. All right. So what is my sample proportion? Okay. My sample proportion is going to be p hat, and that's equal to the number of left-handed students that I saw. How many of them? There's a total of 15 students who are left-handed, divided by how many students?
90.
Did I have 90? Okay, so 15 divided by 90, 0.1667. All right. That is my sample proportion. All right. 18. Let's say you want to make a 90% confidence interval. What critical value z star would I use? Yeah, so for a 90% confidence interval, okay, you're just going to use one of these preset values, all right? And I think I wrote all of them in your confidence interval, all right? What is your critical value? Or in your study guide, okay? Here we're dealing with proportions, so we can look at this. We don't have to go to the t-table. For 90%, we're going to use 1.645. All right. It says when making a confidence interval, what is the standard error? Okay. Again, if you're not sure, you can always go to your study guide and you see for one sample proportions, which is what we're dealing with, the standard error is p hat times 1 minus p hat divided by n. Okay. So I got 0.1667 times 1 minus 0.1667 over n, which is 90. And I take the square root. And you punch that into your calculator and you get 0.0393. Number 20 says, what will be the center of the interval? Okay? Again, look at your study guide if you need to. The center is p hat, and that's going to be 0.1667. You're not right there. The center is the p hat. Study guide. All right. So make a 90% confidence interval for the proportion of left-handed students. Okay, so we are going to put 0.1667 in the center, plus or minus z star, which is 1.645, times my standard error, which is 0.0393. So on the low end, I get 0.1021. And on the upper end, I get 0.2313. That's what I get in the confidence interval. And that's just punching things into your calculator. Yes? These are percentages, okay? They're proportions. Okay? Again, you know, your confidence interval, you should never get a number bigger than what? 1. 1, and you should never get a number smaller than 0. These are proportions. So if you do your math and you're getting numbers bigger than 1 or smaller than 0, and you're dealing with proportions, you know you did something wrong. Okay, yes?
And it says based on your interval is the evidence that the proportion that is different from the nation.
Yeah, okay. So that's number 22, alright? And so we said, is there evidence that the proportion at the school is different from the nation? Okay, so what's the proportion in the nation? 14%. So we ask, is not 14%, but 0.14 in the interval? Okay, is 14% in the interval? Yes, 14% is in between 0.1 and 0.23, okay? Yes, so the answer to our question, is there evidence that it's different? The answer is no, okay? 14% is within the interval. So we do not have evidence of a difference. Evidence that our proportion is different from the national proportion. Alright, so then let me just pause my video right here.